Well, picking off where Mr. Tsubaki stopped, welcome to Unit Circle Mock Exam Review Video Part 2. In Problem 8, we have a circle, obviously. It's shaded, so we have to think back to what is the area of a sector in a circle. Well, we have a wonderful formula. You may not think it's wonderful, but I do. It is theta over 360, right? Because 360 degrees makes up our circle, times, what's the area of a circle? Pi r squared. Now notice we're asked to leave this in terms of pi, which means pi will stay in the answer. So first things first, what is theta? Theta is 60. So we have 60 divided by 360. We can simplify that fraction. Let's go and do that right now. Well, we know these zeros cancel, because it's like saying we can divide both numerator and denominator by 10. And then we can also divide by 6. Right? You see that? And that now leaves us for 1/6 times pi. And what's r? Well, r is 12. And we're going to square it. So let's do this next part. What is 12 squared? It's 144 pi. Okay? And we're going to, how do we multiply this? Well, when you're multiplying with fractions and whole numbers, we're going to put this 1 under. That's not going to change anything. Multiply the numerators. It's 144 pi. Let's see. Can we divide 144 by 6? Let's see. Yes, we can. Now you may think, well, how does Mr. Hayes know that? Well, there's a divisibility rule for the number 6. If, first of all, 144, the last digit is even, so it can be divided by 2. And then if we add each digit, 1 plus 4 is 5, 5 plus 4 is 9. Is 9 divisible by 3? Yes. So the divisibility rule for 6 has to be divisible by 2 and 3. So let's come over here. 144 goes into 6 how many times? 6 goes to 14 at least once. 6. And then I'm left with, oh, that's a silly mistake. No, 6 goes into 14 twice. So it's 12. That's 2. 6 goes into 24 how many times? 4. So our answer is 24 pi. All right. That does it. Not really, because we still have more. All right. Before we jump into problems 9 and 10, we need to understand what our sine and cosine graph looks like. So I pulled up an image of it, and here's what you need to remember about, let's start with cosine, which is in blue. Cosine starts off at 1 right here. Oops. Cosine starts with 1 right here on the y-axis. Then every 90 degrees, okay, increment 90, it goes from 1 to 0, right? Then another 90, it drops down to -1. And then another 90, it goes back up to 0. And then another 90, it goes back up to 1. Okay? So 9 degrees. Every 9 degrees, something, it's going 90, down 1. Another 90, down 1. Another 90, go up 1. And then the 90, go up 1. But it always stays in between 1 and -1. How about sine? Sine here in yellow starts out 0. 90, it goes up to 1. Right here. Then goes down to 0. Goes down to -1. 0. What do you think is going to happen next? It's going to go up to 1. Okay, so remember that. Cosine starts at 1. Sine starts at 0. Okay, so now let's look at our problem.
Is it called sine because it's codependent?
Sorry, there may be some interruptions here because my wife sometimes thinks she's funny. Love you, honey. Okay, so what do we say about sine? We said that your sine, if we want to look back at it, sine starts at 0, right? Okay, so here's the problem. So first things first. We want to first graph the function. Turn this off real quick. And let me fix this. Sorry about that, folks. Okay, so it starts off. Okay, starts at 0. Now notice what it says. It says that we need to make sure to label our y-axis. So let's go by increments because we know it's going between 1 and -1. So how about we make this 0.5 and this is 1. How about we make this -0.5 and -1. Okay, so it's going to start at 0, go 90 degrees, it's going to go up to what? It's going to go up to 1. And then it is going to go from there, another 90, back to 0. Then it's going to go another 90, down to -1. And then 360, it's going to go up to 0. So we go ahead and draw it like so. See the wave? Okay? Alright, now using a different color, we're going blue. We're going to do what? We're going to apply a transformation. What happens when you multiply something on the outside to a function? It causes either vertical stretch or vertical compression. Okay? So we're multiplying by 3, which is greater than 1, so it's going to be a vertical stretch. So what does that mean? We could take each of these values right here, and we can multiply them by 3. Okay? So 0 multiplied by 3 is 0 still. So it starts like that. 1 multiplied by 3, well, it would be up here. Because what? Why? Well, I'd have to continue. This would be 1.5, 2, 2.5. So 3 would be right up here. 3. And actually, you know what? It should be right here. Let me make it better. Okay, and then take our 0 value, right, which we had right here at 180. 0 times 3 is still 0. And then take our -1 value, times it by 3, so it'll be down here. And you know why that was? Because I stupidly, instead of making it go up by intervals of 1, I did it by 0.5. So maybe when you do the test, you don't do what I did, because that's just dumb. Look at this. Look at that verticalness. See? So vertical. Alright. So that's what I have it. Alright, mine's going a little delirious. Okay, so cosine. What do we know about cosine? We know that it starts out at 1. So let me do something better here. This is going to be 1, 2, 3, -1, -2, -3. Okay, so cosine starts at 1. And then it's going to go from 1 to 0. Then 180 it's going to go down to -1. Then at 270 it's go back to 0. Then at 360 it's going to go 1. Okay, so there we have it. That's the parent function. Okay, now how do we do our transformation? I would suggest that you follow kind of as Mr. Tsubaki says it, Pemdas Rule. So what we do in Pemdas, or GEMDAS, whatever you want to say, grouping, parentheses, doesn't matter. You look at parentheses first. So we're going to apply this first transformation, which is the multiplication. 2 times your cosine. What does 2 times the cosine do? That means each of our values that we start at 1, 0, negative 1, 0, we're going to multiply by 2. Okay, so 1 multiplied by 2 is going to go up to 2, right? So it would fall right here. Then 2 times 0 would stay right at 0. 2 times negative 1 would go down in negative 2. 2 times 0, still 0. 2 times 1 would go up to 2. But that's not all. We have negative 1. So what does that mean? That means everything gets shifted down. So then this goes down, right? This one goes down. This one goes down, down, down. Okay? So let's do that. And you can make this better on your test. Okay? I'm just trying to show you how. So it goes back down to 1. It goes down to negative 1 right here. It goes down to negative 3. And it goes right here, negative 1, then 1. Okay, so look at the transformation. Okay, there we have it. All right, moving along. Last one. Try not to get too excited. Give the answer with an exact expression. What does that mean, exact expression? It means that you leave it as a decimal. Does that what it means? No, that's not what it means. It means you leave it as a fraction, okay? So, we're going to use our Pythagorean identity. And that is sine squared plus cosine squared equals 1. So it tells us the sine of theta, or sine of A, equals 1/4. So what we're going to do is we're going to plug in that 1/4, and we're going to square it. So the sine is 1/4 squared. Do we know what cosine is? We don't. So I'm going to leave it cosine. Square theta, right, or A, equals 1. What do I do now? I square this. 1 times 1, 1. 4 times 4 is 16, plus cosine square A equals 1. Then how do I get cosine by itself? I need to move. When you move things, they're always either adding or subtracting. So I'm going to subtract this 116. Bring it to this side. Wait a minute, how do I subtract a whole number from a fraction? I got to make the whole number into an equivalent to a fraction that matches this other fraction. So how could I do that? Well, if I want to be able to subtract 1 from 1 and 1/16, wouldn't it be helpful if I could turn 1 into a fraction using 16? So I can. 16 divided by 16 is 1. So basically we use the denominator and we make a new fraction. So instead of 1, it becomes 16 over 16 minus 1/16. So how do we subtract fractions? Just subtract the numerator. So that's 15 over 16. Is that what we want? No. Because we still have cosine. And so I'm going to come over here and I'm going to do a little bit of erasing. I'm going to erase this bottom part so you can see. And I'm going to say cosine square of A equals 15 over 16. Well, how do I undo the square? If I want just one cosine, I have to take the square root. Well, we can't square root 15, or we can, but we get a decimal. So I'm going to leave this as square root 15. We can't take the square root of 16, which is 4. So now we have the value. Now it says calculate 2 possible values. Oh, well, that's difficult. But remember, when you take the square root of things, your answer can be what? Both positive and negative. So really, all you have to just say, oh, it's positive or negative, because I can have a positive or negative answer. And yes, you'd be correct. And that's how we do it. So thank you for joining me. I hope this was helpful. If not, It's probably your fault. If you'd like me to clarify anything, I would be more than happy to get JT to do that for you. All right. You have a great studying session.